that are ordered list of those events. So one event happens and then another after that and another after that. And there may be a question of why do I need to collect and store them and process them and do all those things with streams of events? The idea is that if you can actually model a lot of things, maybe even everything, as a stream of event, and by getting them into one place on one data platform, you can start building applications that react to those events and do stuff with those events. And this makes your business more agile in different ways. And this is basically what my entire talk is trying to substantiate this claim, that you can actually model a lot of data as streams of events, that it makes sense, and that it brings practical benefits to the business. But you may say, I don't actually have those streams of events. And maybe Oracle DBA or traditional data architect, and all I have is a bunch of tables. Don't worry, we do have you covered. We do think that you may not know it, but you actually do have stream of events. All we have to do is uncover them. So let's look at some examples of those events and see how you may already have a stream of those events. So when most people think about events, they think about it as something that the application reported, usually in JSON format, because this became really, really popular in a lot of applications these days, and something like you have a website and you are selling stuff in a virtual store, and someone came in and decided to view a product, and he clicked on quick view of a product, and this application reported an event. Someone, at this time, this user viewed this product from this page. Fantastic, I have an event. A collection of those from all the users across all my products can be seen as one stream of events. Other sources of events may be sensors. My favorite example is maybe a connected car, where you're driving around and the car reports things about maybe where you are, but more likely how your battery is doing. A lot of most connected cars are electric cars, battery driven, and optimizing the battery is the main competitive advantage of the companies building these cars. They want to collect a lot of information on how the battery behaves under different conditions, especially temperature. So your car will be constantly collecting what is the temperature and how fast the battery is draining, something like that, and you'll have this stream of events getting reported over usually a cellular network continuously from all those cars. Obviously, there is a lot of examples. Sensors are now everywhere. If you have a home security system, it has a lot of sensors. A lot of your home AC heating systems, I'm sure there is a good term for that in proper English, they will report streams of events. I heard some people's tea kettles report streams of events. All kind of things happen. So tea kettles that tweet are absolutely streams of events. And then another very traditional source of streams of events is your application log. Applications always write stuff to log file, activities, sometimes errors. If you want to go and find easy source of events in your organization, go and look at someone's application, look at the log files, and you can see this is a stream of events, right? Someone accessed this page, someone accessed this page, someone accessed this page. One event, one thing that happened after another is a traditional stream of events. What you may not expect as a stream of event is a database. Because, as we said, we have a database, but how do we actually, is it a stream of events? So that's what I want to show you now. You think that the database may be a static table, but there is a whole other way to look at it. So how many of you are Oracle DBAs or have been through Oracle DBA training? Okay, good survey. It's funny, like those events collect people from, some developers, some architects, some people who know Java, some people who are really into Node.js. It's really hard to find a common ground, and it's worse for the joke. Like I used to know that if I go to a DBA event, you make fun of Java developers and storage admins. If you go to a Java event, you really want to make fun only of sysadmins. Like you have this thing on your mind, right? And I'm totally at loss here. So I guess the only thing I can safely make fun of is myself, or expect self-deprecating jokes. Anyway, so those of you who don't know how Oracle works underneath, is that when you do all those updates to Oracle, you think you're updating a table, and you are updating a table to memory, and at some point the table will actually get persisted to disk, so if you stop Oracle and start, you'll have the same table again. But what happens in reality is that not every update immediately gets persisted to a table in disk. It actually first gets persisted to what is called a redo log, or if you use another database, it may be called transaction log, write-ahead log, bin log, etc., etc. And this is a sequential collection of he did an update, he did an insert, he did a delete. And if you crash a database and start it back up, it will look at everything it has in the database files on the disk, and then it will look at this redo log, and it will start saying, okay, here are some transactions that happened, some inserts and updates and leads that happened, but did not make it, they made it into memory, but did not make it into the database files. So we'll have to, basically, it's called a redo log because we're redoing those transactions again from the log. So this log is the real source of truth for the database, which means that we have a log of events. So here's how you want to think about it. Suppose that you have, you're a bank and you have someone's bank account in a database table, account ID, balance. And someone goes and does a deposit and you have an update, please add $50 to the bank account. I'm wildly simplifying. If you're a DBA, don't shoot me on the spot. And you keep doing those changes, and the state of the table keeps changing with it. So you keep adding or keep removing, and every time you do this action, the state of the table changes. So if you do a query, you'll only see the latest, but if you look at the redo log, you'll see a stream of updates coming into the database. So you can see how you have the stream that you can convert into a table by just adding stuff up, and you also have a table that you can actually, by looking at the data, at what's underneath the database, the change log, you can actually convert it back into a stream, which is a very, very popular thing to do in Kafka land and in stream processing land. So we have an entire blog post exploring this a bit more, because it can be, just like the matrix, it can be a very hard concept to wrap your mind around. Like a table is actually a stream can become a table, but it's super powerful once you get it. It means your applications can look at this stream of event and maintain a cache that is identical to what's going on in the database. And we'll talk a lot more on how we can use this duality to do cool stuff in Kafka. So here we go. So we have this stream of events in the database. I hope I convinced you that even though you think you have databases, what you actually have are streams of events. But now we have to get these streams of events into Kafka. Why do we need to get these streams of events into Kafka? Because you can actually do cool stuff with that. The first thing is that suppose that you want to do real-time stream processing, you cannot actually do it if you don't have a stream of events to process. So there is a lot of places you could get a stream of events. For example, you could go to your developers and say, every time someone clicks something in your website, please make sure an event gets reported to Apache Kafka. And technically, it's easy. We're talking about something like maybe 5 lines of code. There is not a lot of magic going on. But we do know that developers can be reluctant to just go and change their code because someone else in the organization just said so. They have priorities, they have things that they're busy, there's always some risks, there's also always opportunity costs. So they kind of need a good reason to do it. While on the other hand, if you go by yourself and just connect to the database redo log and start grabbing data, you can write kind of a POC or example application that uses the same data that you wanted to get from the application. The same things that people do in the website, the purchases, the returns, all of that, you can get it as a stream of events and show, hey, here I am, I built this really cool dashboard that shows in real time everything that goes on in our store. We don't have to wait for the big database ETL load in the data warehouse, at 4 a.m. and then the reports come out at 8 a.m. You have this ongoing, ever-updating view of the system. Our executives love it. Now, I think it will be so much easier if you just report few extra events into Kafka so I can make it even cooler. It's a lot harder to say no to that. So we kind of look at this change capture, capturing changes from a database, as the gateway into real-time stream processing, because it's a very powerful source of streams. So obviously that was nice. Yeah, now you know why, but there is the how. How the hell do we do that? So Apache Kafka shows up with a framework called Kafka Connect, which, as it's called, it allows you to connect it to a lot of different databases, and I'll talk about it in a second. But one of the different connectors that allows connecting includes is connectors to a lot of familiar systems. We're going to talk here about the Golden Gate connectors that allows you to get changes from Oracle, but the Bezium is a project by Red Hat that actually allows you to connect to Postgres and MySQL and Cassandra and Mongo, and the list just keeps growing. They keep adding more and more of those databases. And then there is also other people who are also writing those CDC tools. Pretty much every change capture tool you can think of these days will be able to report data into Kafka, because Kafka kind of became the de facto standard of where do I put a stream of events. So you have this changelog, and you capture changes into Kafka. And what this gives you, and this may be the most important slide in this entire presentation. I said it, and immediately cameras go up. You guys at home should have been in the room. You should have seen it. The idea is that once you collect streams of events into Kafka, you enable data integrations that were actually really hard before. So getting data from a relational database to from an application to a relational database is easy. That's what we always did, right? Our applications did inserts and updates to a database. That's like the traditional way of doing things. Getting data from a data warehouse, from the database into the data warehouse or into Hadoop, that's also something that, especially in the data warehouse, most of us solved something between 10 and 20 years ago. So we know how to do that. But there is a lot of other lines that are either really hard to do, and you have to do them over and over again. Every time one of your developers is like, you know, the data warehouse is not really what I wanted. I want my data in Elasticsearch. I want my data in Mongo. My application will be really efficient if only all my data was in Cassandra. They may be right and they may be wrong, but in the current organizational atmosphere, it is increasingly hard to tell a developer, don't use the tool that you think is the best tool to use, which is very good for pretty much everyone. It's amazing for innovation, but you don't want the same developers to always spend, I don't know, 20% of the time building integrations. Okay, I want to use Cassandra, but the data is actually in Oracle and in Mongo. How do I get data from Oracle and Mongo into Cassandra? So all those lines of communication make life a lot harder. But once you have everything as streams of events in Kafka, it's a lot easier to just connect everything. It lowers the cost of integration by a lot. It doesn't mean the cost of integration no longer explodes as people bring in their pet databases. But even cooler, what if you have an application that needs to get updates from an Oracle database in real time? You definitely don't want it to query Oracle a million times a second. That would be ridiculous. That will be incredibly expensive. But you also don't want it to query Oracle once a day, because it will look at stale data and you'll just get wrong results. You could have triggers, but as the DBA portion of the room knows, we hate triggers. As everyone else in the room knows, it's really hard to get your DBA to add a trigger, because the other portion of the room really hates those triggers. So change data capture into a stream of events that every application, every microservice can subscribe to and get notified in real time. Oh, this guy changed his address. We need to recalculate the cost of insurance. This enables those really cool new use cases, of which I'm absolutely not going to talk about today. It's a totally cool, different application. We're going to talk about getting data, moving data between databases. So we have Kafka Connect, and we have a lot of built-in connectors. This is a very partial list. We have over 50 of them. And if you want to write your own, we also have very good guides on how to write an example one that is just POC, and then all the extra work you have to do to make it production ready. There's always a catch, right? It's like 15 minutes to the first version and another 2 months to get a real version. It's not as bad as 2 months, but there's always this thing about production. But a lot of stuff is already ready out there and production ready, and you just need to install a connector from the Confluent Connector Hub. Most of them are open source. And no, don't ask me for an open source version of Golden Gate. I can tell you right now, we don't have an open source version of Golden Gate. You may find cheaper versions of Golden Gate if you go to Golden Gate competitors, but as far as I know, there is no open source equivalent that just makes everything free. One could wish, but nope. So this allows you to do this data integration. Stream events into Kafka via Connect and stream events out. And that way you can get events out of MongoDB into Elastic, out of Oracle, to Hadoop. All those different lines of integration are suddenly a lot simpler than they used to be. But as everyone who has experience with ETLing and data integration knows, this is not, you cannot actually do it. Like you cannot, it rarely works that you can take an event out of a database and just insert it nilly-nilly into another database, because you'll inevitably find out the data types are different. There is this one extra column. There is a security. This is PCI certified, but the other one is not PCI certified, so you have to leave out all the credit cards. There is a lot of things that go wrong in the middle. But before we get to that, let's talk a bit about the scale part of it. So when people think about, especially modern data platforms, and especially when we say it's a distributed real-time platform, you always think about scalable, like Google scale, Facebook scale, and they're like, I don't actually have this scale. Like, I don't know, some of you may be working for Facebook and Google, but most of us really are not. But that's only one dimension of scale. The really scary scale here is the number of projects your organization is running, the number of different databases that developers need to make talk to one another, and the rate at which this is growing. So it's more about the diversity of data and the need to store a lot of events from those sources, because who knows if they will be useful, then it's not about being Google. And the nice thing that Kafka Connect adds here is that the way it works is that you install those worker nodes, and then you can run pretty much any connector on them. So today you're integrating, and literally today we're integrating Oracle with Elastic, but tomorrow someone comes to you and says, hey, I actually have Cassandra, I don't have Elastic, can I get the data there? And you tell him, here is the REST API, go knock yourself out, get the data in there. I don't even have to be involved. And this is really powerful. And this is something that when I talk to my customers, a lot of time the story here is that I got some data from MySQL to Kafka for my own use cases I needed for an application, and now everyone comes to me and not to the DBA and says, hey, I heard you have all the data from MySQL in Kafka, can I come and grab it? And unlike the DBA, the database, Kafka was made to scale to pretty much an infinite number of consumers, because you're not running a heavy query, you're not using all those CPU resources, you're not taking logs, you're not using latches, you don't have mutexes. All you do is basically say, every time you have a new event, send it over. So as long as you have connections to Linux, and this can be 5,000, 10,000, you can grow there. And when you're out of those, you can add additional machines, because that's where the distributed part come out, you can scale out. So this is what I mean when I say at scale. And under the covers, as I said, there's workers that are running tasks. Every task basically goes out and pulls events from a database or pushes it out to a database. And the nice thing is that Kafka Connect manages a lot of the concerns about reliability and scalability for you. So for example, imagine that one of our workers died. Kafka will make sure that all the tasks that run on this worker will magically migrate to this other worker. So this is something this is what we mean that it actually takes a lot of the concerns away from you. You don't have to worry about, oh my God, I have this script in Perl that I wrote that gets data from this database to the other database, but what happens if it crashes? This is kind of the Kafka magic. And another thing that it takes care of for you is that a lot of time when we write those scripts that get data from place to place, they lose the schema information. But this is actually important information. You want to know what are the fields in my data, what do they mean, and are they integer or a string or a timestamp or what the hell is going on? So this is another thing that Kafka Connect will manage for you under the covers. And another very good topic for presentations that I'm not going to talk about right now. The things that I mentioned earlier is that you very rarely actually want to get data as is from place to place. You want to do some processing in there. So Kafka Connect shows up with a single message transform, which is a set of plugins that allows you to basically take a single event, do something to it, and put it back in place. For example, take out the credit card numbers because the people on the other database are not allowed to see it. Things like set a partitioning key because you know how the data is going to get partitioned in the other system. Things like store lineage. Where did the data come from? Maybe some rules. How are people downstream allowed or not allowed to use it? So you can do a lot of this kind of processing magic on the fly. But note that this is simple event, single message transformation or simple message transformation. It means that you cannot modify, you cannot do things that act on large sets of messages. So example, the easiest, you cannot do an aggregate. You cannot do a moving average because that involves more than a single message. You cannot do a join. What do you do if you actually want to do a join or a aggregate? I mean, that's not an unreasonable thing to want to do in your pipeline, right? We really, really want to do it. And this is where KSQL shows up. So everything I talked about until now was part of the Apache Kafka project. This is still Apache licensed open source, but by Confluent. It is not part. If you go to kafka.apache.org, you'll see everything I talked about except this. If you go to github.com/confluentinc/KSQL, you'll see KSQL. So this is the SQL engine. There's a lot of other ways to process data in Kafka, but I figured that if we were an Oracle event, you guys will appreciate some fun SQLing. So the rest of the presentation, I'm going to show you what can you do with some SQL on top of Kafka. So the idea is that if you know SQL, you can do real-time stream processing. This is the promise. We make it easy, and like everything else I talked about, it's scalable and it's fault tolerant. And you don't need to deploy complex event processing systems and really odd clusters. So the easiest thing you can use KSQL for is just to look at your streams of events in Kafka. Like just say, hey, I have this click stream. I'm wondering, do we even get anything from Mozilla 5.0 on our website? Let's take a look. Let's see the last 5 messages, in which case you'll put a limit there. So this just allows you to explore your streams a bit. But if your streams are really large with tons of data, this will just overwhelm your screen. You'll see messages just floating. You won't be able to do that much with it. The really powerful thing starts when you start creating tables from streams. We'll talk about it a bit more in a second. And then you can actually do a bunch of data analysis on the fly. So suppose that you want to know every time you have a stream of credit card authorization requests, and if someone tries the same credit card 3 times within 5 seconds, which is usually not something a human would do. It kind of indicates a bot. You want to mark it as suspicious. Maybe you won't immediately block their account, but you'll definitely flag it, hey, something weird is going on there. Maybe you'll automatically SMS the person, hey, are you trying to buy this at that store because I'm getting repeated authorization attempts. This is all you need in order to do it. You do a select card number, you do count star, you have a 5-second window, you group by account number, and you want to have more than 3 authorization attempts in a 5-second window. Is it going to be fast? Because, hey, you may have a lot of credit cards. That's where the scales come out. You can just run it on a lot of machines. At the end of the day, if one machine processes a small enough subset of credit cards, this can be ridiculously fast. Another thing you can do is do some monitoring. If you have a stream of events from an application and you want to know about errors, this is how you do it. You want to know about errors that have more than 1 error in a 1-minute window, you can get the list of those errors that happen so frequently. This is also good for IoT data. You have your home security device. If it keeps sending errors in every minute, you may have a problem. So you can do those. And then probably our most common use case is not as much as generate alerts as just transform one stream into another, which is what we're going to do today. You basically you have a stream of actions, but you really want your application to only get notified when there is an action by a platinum user. So you create a new stream of events, which is only the platinum users, and you make your application subscribe not on the original actions, but on the new VIP actions. So we talked about like 3-4 use cases when this is a really good fit. But as you know, even though I always think that every new technology that I worked on it absolutely cure cancer and is good for everything ever and will solve every problem and make everything easy, We all know that in the real world, there is nothing is perfect. So some things you probably don't want to use KSQL for is for ad hoc queries. Kafka doesn't really have indexes. So KSQL works very well on processing data that arrives in the future. But if you want to just look at data that you kept in Kafka for months, and it's 14 terabytes, and you're writing this query and you expect fast results, this is going to take a while because it's going to be exactly a full table scan of X terabytes of data. So be careful doing that. And because of this lack of flexibility, because we only process data that arrives from the point we wrote the query into the future, it also means that things that require a lot of slicing and dicing of the data, like connect Tableau and start visualizing using your data in 15 different ways, not going to be a good fit. Also, we don't have a JDBC driver yet. So you're going to have to use our APIs to run the queries, and Tableau doesn't really know about our APIs. So even if we had indexes, this integration wouldn't work. But as is, it's just not a good fit. But this is kind of what we imagine you're going to do. You're going to get data into Kafka from your applications or from databases or from log files. You're going to run some KSQL queries to process this data, and you're going to push the results into another system that absolutely allows you to do slicing and dicing. And this is what I'm going to show you in a second. So when we look at this pipeline, it basically has three parts, right? It has the extract part, the load part, and in between the transform part. I'm going to talk about them in this order. So starting from getting data out of Oracle into this is basically the pipeline we're building here. Note the blog post in light green on the bottom. This is basically taking you step by step on how to do it, like how to get the data into Oracle. We're using Swingbench, if you're familiar with it. It's a load testing tool that runs on Oracle. And it has this fake store orders schema. So we're going to generate data using Swingbench. We're going to get the data from the Oracle redo log into Kafka using Golden Gate. And the blog post talks you into detail how to do that as well. We are going to do some processing using KSQL. And then we'll use Kafka Connect to get the data into Elasticsearch and draw some pretty pictures. Looking at how we get, imagine that Swingbench worked. How do we get data from Oracle using Golden Gate? The usual way, you have Golden Gate. Golden Gate has Connect handlers. You can download a Connect handler for Kafka, and it will get data from Golden Gate to Kafka. This is not a Golden Gate talk, so I'm not going to dive into a lot of Golden Gate details. I've spent the last 10 years of my career trying to run away from really understanding Golden Gates, and so far I've been successful, so don't make me do it. But you can see we have an entire blog post on how to install Golden Gate and get your data into Kafka. But then, suppose that you somehow made it, what is really important is to validate that it works. So you'll want to insert some rows into Oracle. Make sure that you have the right topic existing in Kafka. So you list the topics, and here we go. And then you want to start consuming events from Kafka. Remember, it's a consumer right now, it's not a query, so you just listen to the stream of events, and you say, I want the events that are getting published right now onto this topic, and we use JQ to format them nicely. And if all went well, this is what you're getting. You'll just see a stream of those. I had this table, we have an operation, this is an insert, this is the timestamp, we got a login ID, a customer ID, and a logon date. So, and this is one event, and you'll just supposed to, every time you do an insert into a table, you're supposed to get another one of those. You do an update, you'll get op type U. So this is really, really cool. And then the other part is that you want to get data, note, from Kafka to Elastic. And we use Kafka Connect. So far we used Golden Gate, and now it's time to use Kafka Connect. And we basically say we want an Elasticsearch sync connector. The connection URL is the Elasticsearch URL. The data comes from this topic, goes to this Elasticsearch index. And in between, we told you about the transformations, that sometimes data doesn't exactly fit. we're changing the timestamp from whatever it is that it's kind of a binary format that we hold in Kafka into a formatted string. So those events go like that into Elastic. And the way you run it, you do Confluent load, and you define a new sink, and you give this JSON I just described with the sink definition. And then you take a look at what you get out of Elastic. And in this case, we can see that Elastic returns data. Or you can go to the Elastic UI and make sure that you can see the index in Elastic. But best of all, if you installed Kibana, you can actually create all those nice reports and do all kinds of cool slicing, dicing, and data analysis in Elastic. And this is without any processing except the simple replacement of a timestamp. So this is like the simplest pipeline possible. You can all do it in like 10 minutes. But let's do other cool stuff. Yeah, you can do some really impressive stuff in 10 minutes, by the way. So when we look at the example swing batch schema, we can see that we have 3 tables that we're going to talk about. They have more, but we're going to talk about 3 of them. We have the logon table. Every time someone logs in, you get an event, someone logged in. This is a stream of events. We have orders. Every time someone tries to buy something, you have a new order. This is a stream of events. The customers, on the other hand, most of the time it doesn't change. It's kind of a static table of customers. Every once in a while, you get a new customer, or a customer changes his address or class or language, and then you get an event that doesn't update. So this is what we'd call a slowly changing dimension, right? It's still a stream of events, but a very slow stream of events. So the customers we're going to actually model inside KSQL as a table. We'll try every time we look at it, we'll just look at the current state. Everything else we'll model as streams of events. And let's talk about how we do some data analysis. So the first thing is we want to say, let's look at the stream of changes that comes from Oracle database and model it as a table. Basically create a small cache in memory with an exact copy of the table in Oracle. So every time we want to know, hey, what's the customer name, we don't have to go back and query Oracle for it. And here you have to specify all the columns because we're using JSON. If you used Avro, then this would have been automatic for you. I think the blog post actually shows you how it happens automatically. And then let's just see if it works. Let's select few customers, and you can see a bunch of customers. I'm not explaining the SQL because I kind of assume you all know SQL. If anything is unclear, kind of wave your hands. I'm also running fast because I know how much time I have left. The next thing I want to do is to take the logons. So logons, I do want to model as a stream of events. When I did a select, I don't see all the updates and inserts that happened in order to get Carl Green to be an occasional customer. There may be 5 updates before that, but I don't care about them. I want to see the latest state of events. When I look at the logons, I don't want to just see the latest logon. I want to see every single logon by every customer, so I model it as a stream of events in exactly the same way. And again, we can do a select, and we get the last 5 events. Fairly simple. But now the really cool stuff is that we want to enrich events. And I don't have much time to convince you that enriching a stream of events is actually a hard problem with pretty much everything except KSQL. If you try to do it in Spark or in Flink, you will find out that you have to create this in-memory cache yourself, and you have to do hash join, or you have to go and call the database every time. No matter what you do, it's going to be a bit complicated. We make it basically just a join. You have no idea what machinery we're doing underneath, but I can guarantee you it's a lot of machinery. What we want is that, remember the logons, they have customer ID, which is nice, but we want the customer name and we want the customer class. So we do a join, and we get the customer name and customer class, and now this is what the result will look like. What if we want to do more? What if we just don't like this formatting at all? We can do more. We can concatenate the first name to the last name to get a full name, and instead of how long they've been a customer as a timestamp of when it is joined, you actually get, we do some more advanced casting and calculations, and you know how many years they've been a customer. And Now you can get this process stream of events. And the nice thing is that note that we're creating a new stream of events. Now we have logons enriched as its own stream. So we can go and query, go to logon enrich, and get us all the customers who are prime and have been a really, really loyal customers. So you get this really nice subset of customers just based on the latest data. And this is really powerful. You process events from one stream, you create a new stream, you grab events from the other stream. This is basically how we build ETLs with a lot of small microservices in between. So we have those input topics. We did a create table. We created a stream. We joined them. We got a new stream as a result. And we're dumping it with Kafka Connect into Elastic. As a result, we have really nice graphs about how long customers have been there, how to correlate the frequency of logins with how long someone has been a customer. You can really slice and dice the data, this pre-processed data in all kinds of cool ways. How many customers do I have from which type, et cetera, et cetera. You can create very quickly incredibly impressive dashboards. And remember, the whole goal is to very quickly do something really impressive with the data so you can gain political capital for your next project, right? So this is like the easiest way, to successfully get buy into your next project. Look what I did in just a day. Give me a budget. But of course, joins is not enough. Usually, we also want to aggregate the data. So here we aggregate the order table per hour, how many orders and what is the largest orders that we got from each customer type, in each order status per hour. And so we basically, again, we create a table, not a stream. We want a summary. And when you do a select from the table, you can see that for each hour and each order status, we have how many orders existed. And because all of them are one order, the maximum and total are kind of similar. But I swear that it doesn't have to be this way. And then because this is a select from a table, but you can also use normal Kafka tools to just show you the stream of events straight from Kafka. And because it's a stream of events straight in Kafka, you can, once again, get this back into Elastic. So in this time, we got a stream of orders, and we did an aggregate. We collided it per hour, and we created a new topic, which we stream into Elastic in order to generate our really cool graphs. I think by now you kind of got the idea. Cool graphs. Heat maps are where it was, I think, about 5 years ago. I don't know if they're still considered cool or not. I think now it's flame graphs that everyone talks about. So just to summarize, because I have 3 minutes left, we got events from Oracle. We got events to Oracle using SwingBench. We got events out of Oracle and into Kafka using Golden Gate. We used KSQL to do really nice analysis with just few simple queries. The results went into Elastic, where we could easily visualize them into cool graphs. And in about an hour or two, we have something really cool to show our team. If you get caught in a crunch, it's demo day, you have to show some things that you did this week, and you don't know exactly what you did this week. Where did all the time go? And of course, this was our example, but it works in the generic case. Data can come from pretty much anywhere. You can do all kinds of cool transformations. And if Elastic is not your data visualization of choice, you can get the data back into Oracle, or you can get data into a data warehouse, or wherever it is that you know how to visualize from, that's where the data should go. If you really liked it and you want to follow up, other than my book, there's some free resources out there. If you want to use KSQL, you go to GitHub. If you want the entire Confluent platform, including Kafka and the schema registry and a bunch of connectors, but not the Golden Gate connector because that belongs to Oracle, you go and download the Confluent platform. If you want to read more about how to do it, remember we had a bunch of blog posts on how to use Golden Gate and how to use KSQL and how to build this entire pipeline. And if you have questions and don't feel like paying us for support, we actually have a Slack community. So you can go in. We have a channel for Connect. We have a channel for KSQL. We have the channel for I'm a newbie and what the hell am I doing? Nothing works. I got sold lies at the conference. This never happened to me before. So you can go and ask questions. We have 3,000 people in the community. The chances of getting an answer are actually ridiculously high. And you can also ask me on Twitter. But not about Golden Gate, that part I don't actually know. So yeah, thank you all for being here. I have like 1 minute, so maybe one question, and then I'm around all day, so you can grab me at lunch or something. Yes?
How does Kafka avoid data loss? In a sense,
Okay, this is a huge, I have an entire presentation about reliability in Kafka, but in super short, every piece of data that you write is duplicated to 3 machines and written to disk. So you need 3 machines to have a really serious disaster and at least 3 sets of disks to die in fire. If it's RAID 10, then you need like, I don't know, 3 times 12 sets of disks to die in a fire. So it is pretty safe. But you have to configure a lot of stuff correctly, which is why I recommend going and searching for reliability in Kafka and getting a long list of stuff you have to get right, because it is actually fairly easy, just like in Oracle, to accidentally mislay your redo log and lose all your data. Yes? That's a fantastic question. So he asked if there is any kind of ordering system to messages in Kafka. And I'm sorry that I didn't make it clear. This is like the biggest thing in Kafka, and what really defines a stream of events is that the messages will always be preserved in the order in which they're written, and they will always be consumed in the order in which they're written. And this is like key to the whole thing, right? Because obviously if it's my bank account and I deposited 500 and then I withdrew 500, it's a very different experience. And I'm out of time, and Google actually worked. Thank you everyone again, and I'll be around for questions.